I see a whole lot of people have already arrived, and thank you. It's nice to see you folks again. Let's start off as usual. I'm going to adjust my screen here a little bit. You can see all my ceiling. And I got a comment from someone at some point. So yes, in the back, on the top there, that is an almost original Macintosh. And sitting next to it is a Next machine. I guess that's why it's next to it, right? Oh, but surely I kid. Anyway, so yes, I am a dinosaur, and I collect dinosaurs as well. Oh, the Next machine, I actually did use the Mac. I got from someone else who was selling it years and years and years ago and didn't really want it anymore. So there you go. Okay, so let's, excellent, excellent. I'm glad you're able to show up. The whole point of this class is it's very free form. You don't have to worry about, you don't have to apologize. It's great that you're coming when you are here. All right, I'm gonna grab the exercises from there. And I think I demonstrated last time that I'm terrible at turning into a markdown of some sort. So I'm just gonna like quickly reformat this stuff. But it was funny, I was in a Zoom webinar yesterday. I know like the whole world is doing this, but it was one of the first times, if not the first time, I was like on the participant side rather than on the running things side. It's kind of like funny, oh, you don't have this control, you don't have that control. Only the person in charge has all the controls. All right, now that I've demonstrated how totally like ridiculous things are. Okay, so let's actually put this in a markdown here. Yay, look at that. Okay, very fancy, very fancy. Okay, so now what I want to do is, so create a dictionary name menu. So this is what I call my restaurant exercise. So we're going to create a dictionary name menu in which the keys are dishes at a restaurant and the values are prices. And this is to demonstrate to you something I think I mentioned last week, but it's worth repeating. The dictionaries can be used in a whole lot of different ways. And one common way is as a little, oh, I haven't shared my screen. Wait a second. Oh, let me just share the screen. That would explain why like I didn't see all the like fancy controls and everything for screen sharing. Hey, Leon. The redneck from Flint, Texas. Please, please. All right, excellent, excellent. Let's see it. Bring the chat up in another window so I can actually still see it. And oh, they're fantastic. Okay, so again, like you can use dictionaries as sort of like little databases inside of your program, and then you're not going to change it. You're just going to query it. So that's what we're going to do here. So first of all, I've got to set up a menu, and like it doesn't matter what the dishes are. It doesn't matter what the prices are. So I'm going to make some arbitrary amounts here and arbitrary dishes here, and you can translate into whatever your favorite currency and or hyperinflation is. All right, so let's say I want to get like I don't know, a sandwich, right? And we'll say that's, I don't know, put in shekels, even though that's like a cheap sandwich. We'll make it 35 there. All right, and then I'll say if I want a cup of tea, let's call that 10. And if I want, I don't know, like a cookie or something, I don't know, let's call that, we'll say it's like 15. And we'll stop there. It's a very limited fare restaurant. Okay, so now what? Well, we want to ask the user, what do they want to order? And we don't know how many things they're going to order. Actually, you know what? Let's start off with ordering one thing, and then we'll add to it a loop that we can order multiple things. So I'm going to say here, let's say order equals input, enter your order. I'll even do a strip here, just for fun. And then what? Well, in a dictionary, we have keys and we have values. I want to see, is the user's order in our dictionary? So I can say here, if order in menu. Now remember, that is only going to check the keys. It is not going to check the values. So it's going to check, is the string that we got from the user sandwich or tea or cookie? All right, and this is going to give us, the in operator gives us a yes or no, a true or false value. So if it's there, then what? Well, now what we want to do is find out how much it costs and tell them. So let's say here, price equals, and look at how I can retrieve, oh, my data entry is still not showing? Let me know if it's still not there. It should be showing. Let's see. Do people not see it? If they don't see it, I'll like reshare. Let's see. Oh, you can see it? Okay. Well, as long as Jason can see it. Ha, tough luck for the rest of you. All right, so let's see. Screen share. Let's do this. All right, so what I'm going to do is here, I'm going to say price. And notice, price is going to be what? Menu of order. And this is the key, so to speak, of what's going on. If basically I'm going to my dictionary, I'm saying I want to retrieve the item, the value associated with which key, whichever key the user gave me. And you see now how this goes together. We're using a variable here, which happens to be a dictionary. We're using a variable here, which happens to be a string. And together they're going to give us a value, which is, in this case, an integer. And then what I can do is I can say print, and use an F string and say, order costs price. Okay, that's pretty good. That's pretty good. We can then say else meaning it's not there. So I can say print, sorry, but we are out of order today. So let's try this. So if I say here sandwich, it'll say sandwich costs 35. And if I say, elephant, fresh out of elephant today, just my luck. So you see how basically I'm able to, as the user, enter this string, and then we're going to look at the dictionary. I want to put this into the Python tutor so you can see a little more graphically what's going on and how these things are interacting. And then we're going to put it into a loop so we can do this again and again and then get something more there. So visualize your code. Really need to just like bookmark this link because I go here so often. Okay, here we go. So let's do this. Visualize execution. So watch what's going to happen. Make this a little bigger maybe for you folks. There we go. So first thing, we're creating our dictionary. Look at what the dictionary appears like. It's like a 2-column table. Keys, values. We always retrieve the value via the key. We always search on the key. The keys are key. And now it's asking me for input. So I'm going to say here, I want a cup of tea. So it's going to say now what? Well, it's going to say if order in menu. What's it going to do? It's going to say, well, order here is the string T. Is order in menu? This dictionary here, is it one of the keys? The answer is yes. By the way, if punctuation is different, it won't find it. If spaces are different, it won't find it. If it's misspelled a little bit, it won't find it. It must be precisely the same thing. And that's why I think I might mention this like a while back when we were learning about strip to remove the white space from either side of a string. But if you've ever logged into a website and it says, sorry, your username is not correct, and it is, it sometimes can be because, you used a space there. So this can be maddening, but this is how it's working. It's retrieving it via that space, and that space changes everything. So that's it, right? So now we're going to get the price. Price is now 10, which is indeed our price. And we can print it, order cost price, T costs 10, and that's it. And if I go back and I run it all over again, so we got a dictionary, I'm going to get my order. Oh, I see. I need to actually like start it again. So let's do that. I'm going to just like edit and then run again. So now if I go through, okay, there's my dictionary, and I'm going to say, whatever. Okay, so now is order in menu? No, it is not. And so what's it going to do? Now it's going to print the else, and we're there. So this is how we could use a dictionary as a little database here. But let's then turn this into a loop, which is what the exercise really asked for. So I'm going to take all this, and now I'm going to say here, this sort of thing, while true. And I'm just going to go around and around until they give me a blank order. So I'm going to say here, if not order, break. Meaning, if we got an empty string. Because why if not order? Because if looks to its right, it says, is this true or false? Not looks to its right and says, is this true or false? Well, order is neither true or false. It is a string. Strings aren't true or false. They're a different value. But if it's an empty string, it's considered false in that context, and then not turns it around, and if checks for that. So this is a fancy way of saying if we got an empty string. Okay, well then what? Then we'll break, fine. But I'm gonna have to total up because we might be getting a bunch of things. So total equals 0. And then here, I'm gonna say order cost price, total is now total. And then at the end, I can say print, total is total. So let's go through this, and then we'll go through the tutor as well. So I'm gonna say here sandwich, then 35, total, oops, I forgot to add, forgot to add to the total. You ever been to a restaurant like that? Yeah, all right, so we're gonna say here, total plus equal price. Okay, so I'm gonna say here, sandwich. It's gonna look up sandwich, get the price of 35, add it, total's now 0. Oh, because I did it before. There we go, good old logic problems there. We have to do it actually before we print it. Okay, 3 times the charm. Sandwich, I really want a sandwich. Okay, sandwich costs 35, total's now 35. Cup of tea, now total's 45. I have a cookie, right? And while I'm having a cookie, I'll also have, I don't know, a cup of milk. And it'll say, sorry, we're out of cup of milk today. Also out of grammar. And I press enter, and we are done. It says the total is 60. So what if you had spaces only? Oh, fantastic question. The answer is yes. Because strip removes all the spaces, we'll end up with an empty string. So yeah, if I say like, sandwich here, just to show you, I'm going to put spaces here. So we were saved by the fact that we had a strip there, and it turned into sandwich, even though it was sandwich space by space. If I press spaces here, it exits. It sees it as a blank string, absolutely. So I'm going to paste this into the Python tutor. Great question. And now let's run this. So visualize execution. Same dictionary as before, which is good. Total starts at 0. So now we've got a variable there. And now we're going to go around in a loop. And I'm going to say sandwich. All right. And it's going to say if not order. So is order an empty string? It is not. So we keep going. Is order in menu? Yeah, it is. So we're going to grab the price. Price gets set to 35. We're going to add price to the total. Total plus equal price. Then we're going to print out a little message. Then we call 35. Total is now 35. And we go back to the top of the loop. And then we're asked for another thing. So I'm going to say here, cookie. Big on carbs today. All right. And then we're going to say here, next. Right? Because it wasn't blank. Is it a menu? Yes. We're going to add its price. And we go back up to the top. And you can see that we're accumulating in our total, well, the total. And now if I say something nonsensical, all right, here we go. We go next. And here we go. It's not in order, not in the menu. It's going to say we're all out of that. And finally, if I just give it nothing, we're going to exit, and it will print the total. There we go. Total is 50. So this is how we can use the dictionary as a little database. And it's really, really common to do this sort of thing. In fact, you can have, of course, multiple dictionaries. And so simple things you might want to do with that. Months of the year. You have the keys be the numbers and the values be the names. Or if you have a program that wants to be multilingual, multinational, then you could have two dictionaries, one for the main language and one for a secondary language. And then you pull out from the appropriate dictionary which language you want for printing the months or printing something else. That's a way trickier problem than I just described. But for a really, really simple sort of localization and internationalization solution, you could totally do that. You could have like error messages listed there. So error 123 gets the text of that. You could have your users. There's so many things you can have here in a dictionary. And inside of your computer, inside your operating system, inside of Python, there are lots and lots of dictionaries as well. Additional questions about this exercise. Then we'll look at the other one, and then we'll start talking about files. Any more questions? I'll just take a sip of tea since we've been talking about food and drink. Okay, so let's look at the next exercise. So here I was a little ambiguous, so ambiguous that several people in the forum, and I'm sorry I didn't get a chance to respond to everyone, several people in the forum answered it one way, several people answered it the other way. I will answer it both ways. And I'll tell you how I originally planned it and then what actually happened. So the answer is, the question is, ask the user to enter one word at a time. When the user enters an empty string, nothing, stop asking. And use a dictionary on how many times each character appears. And I meant each different character, not each category of character appears across the user's inputs. And my point in doing that was to show you can start with a dictionary that's empty and then little by little populate it. By the way, fine, let's just do this here. If I get rid of the blanks at the beginning there, then I think Markdown looks like, there we go, fancy, fancy, right? Okay, so how am I gonna do this? I'm gonna ask the user to enter a string. And then let's do this once again, once. And then what we're going to do is we're going to do it for multiple words. So I'm going to say here like counts equals an empty dictionary. Very important, empty dictionary. We don't know what we're going to get in advance. And then I'm going to say, okay, let's get a word from the user. So we'll say one word equals input, enter a word. And we'll do a strip on that too. Now I want to count how many times each letter appeared in this word. How am I going to do that? Well, I have to go through each letter in the word. So let's do that. For one letter in one word. And then what? And then I'm going to say for each one of these, if it's already in our counts, we'll add one. And if not, then we'll set it to 1. So I can say here, if one letter in counts, 1, so we'll say counts of one letter plus equal 1. Otherwise, what? We're going to set it to 1. Counts of one letter equal 1. So let's see print counts. Let's see how this works. So I'm going to say hello. And it's going to show me now that H appears once, E appears once, L appears twice, O appears once. Because what's happening? We're going through each letter of the word. And each one we're saying, is it in the dictionary or is it not? And it's really important that we start off by resetting our dictionary, because heaven knows what we had before. Right? You imagine now running it again, and if I don't reset the dictionary, bad news. Am I stuck with only entering a word? No, of course not. I can say here, this is a test. And now it's going to show each of these letters here. Someone raised their hand. You can just put the question in the chat. It's probably the easiest thing, and I'm happy to answer them. You don't have to be so formal and raising your hand, but it does like pop up on my screen, so I know at least that there's a question. So that's good. I'm going to keep talking, and when I see your question, I'll be happy to answer. So what we see here is we went through each of the letters. Oh, Andy's also raising hand. Just put the questions in the chat. I think is the easiest thing. If you don't see the chat, let's see. I'll put it here. Yeah. Hello. So if you're like raising your hand because you have a question or something or a comment, please just go ahead and put it in the chat. That's the easiest thing for me, I think. So you can see that we got T and H and I and S. All that's good. But I also got a space, 3 spaces, right? Because what did it do? It went through what we entered, and here's a space character, here's a space character, and here's a space character. And if I were to do something even wilder, where I would say, hello, I am a very excited sentence. This is part 3. And so we see here, we have like all these characters, and each one of them is seen separately. Also notice capital I, totally separate from lowercase I. Oh, and so Ronnie's saying, I somehow understand I should do it with a while loop. So what I did just now is I just did for one word. What I wanted, though, in the exercise was to do it for multiple words. So yes, you're totally right. So now that we've got it working once for one word, for one sentence, for one input, now let's put it into a loop. So now what I'm going to do, I'm going to take all this, and I'm going to say here, while true. Oops. And now I'm going to say here, one word equals, I'm going to say if not one word, break. Meaning, if we got blank input, exit the loop. And then at the end there, we're going to print it out. Ronnie says, outside the for, and enter each word different. Yeah, that's what we're doing here. That's what we're doing here. Exactly. So what are we doing now? We're going to get a word from the user. Could be a word, could be a sentence. Really doesn't matter. We're getting a string. Probably shouldn't have called it one word. And then we're going to say, did we get something empty? If we did, then we're going to exit. But meanwhile, what we're going to do is we're going to go over each letter that we got in that word, and we're going to count it. And so this way we can sort of accumulate over time. So this is a test. This is really a test. This is, getting to be a boring test. Goodbye. Enter. And we see now we have a count of how many times each character appeared across each of these things. Let's say we want to do something ever so slightly different. First of all, any questions about this? And then I'll show you one more different thing, and then we'll start talking about files a little bit. Any questions about this? More questions, I should say. Okay. Let's say I don't want to count characters. Let's say I want to count words. For example, a word processor might want to tell you, hey, the following words were used very often. Or if you ever use one of these grammar checkers, like what are they doing? They're very often, it's very sophisticated software, but it's very often looking at how often you're using certain words, and then they're able to recommend things. So maybe I'm not interested in counting letters. Maybe I'm interested in counting words. Well, watch this. It's basically going to be the same, almost like 90% the same. I'm just going to change some words here. So one word will be one sentence. Sentence. Have I really changed anything? No, of course not. If not, one sentence. Still not so great. No, not so terrible. Now here's where I'm going to make a big difference. One sentence split one word. And one word. Look what I'm doing now. I'm actually not counting the letters. I'm counting the words. And so what I'm going to be doing here is checking how often is each word entered. So this is a test. This is another test. Have you ever taken a test? I don't know, and worried about the results? I'm not doing punctuation on purpose so we don't mess things up. Well, this is one of those. And I press enter, and look at this. It counts how many times each word appeared. This 3 times, is 3 times, a twice, test 3 times, and so forth. So we're able to go through and accumulate information about things. Now, again, you might say, oh, come on, like who's going to do this? Actually, tons and tons of programs do this, right? Think of your web browser. Your web browser remembers what URLs, what addresses you visited before, and the more common ones are at the top, and the less common ones are at the bottom. How does it know? it's probably storing it in a history that's in something like something like a dictionary. Oh, can you print row 9 of the split? Yeah, absolutely. Well, let's see. Here, I'm gonna split as it were. I'm gonna turn it into Raven says, well, if I don't want to count certain words like this. Fantastic. I'll do that in just a moment. So I'm going to say here, sentence list equals 1 sentence split. I'm going to say print sentence list. And then we can just say here in sentence list. All right, so now if I say here, this is a totally new sentence. We see here, so sentence list is this. This is what happened to our sentence when we broke it up. So we entered a string, we turned it into a list, and then we iterated over every element in that list. And then I say, this is very serious and must be treated appropriately. Right, and so you can see here that it's still counting things. So what we're doing is, we are taking the original string, we're breaking it into pieces in our list, and then we're iterating over the list and using that to populate our dictionary. That in this particular case, the dictionary's keys are the words, and the values are the counts. It would only count if it was a list, not a string. Yeah, I mean, well, if you go over the string, then you get it character by character. That's what we did in the original version. Now, Raven says, very rightly so, what if we don't want to count all the words? And you've probably heard, you might have heard of this. So when you do like parsing of text, for example, your spam filter, right, other such things, it doesn't care about words like a and the and so forth. Right, those are known as stop words, right? It's going to ignore those. So how can we do that? I can create another dictionary. Actually, I can even create a list. Just say here, ignored words equals, this is the. So now what I can do is I can say this is a test. Oh, I forgot to actually do something with it, right? So we should say here, if one word in ignored words, continue. Meaning, I'm going to go through each word in the sentence list. But if this is one of the words we should ignore, we're going to ignore it. So now I'm going to say here, this is a test, and this is the best thing I have ever done. That is very sad. Enter. And you can see here that indeed it counted how many times each word appeared, but it ignored the words in our ignored words list. And so I hope you're seeing how we can take these data structures and really do some amazing things with them with very little code. The building blocks we've been using so far are real and powerful. And those of you who ever used a language like C or C++ or Java or C#, people come to my courses very often from those languages, and they're like, oh, Python's a toy language. It doesn't do very much. Like, what can you really do with it? It just has a few data structures. And after like a day or two of my course, it's not because of me, it's because of Python. They're like, oh, wait, you can actually do quite a lot in very little code here. And I don't have to like spend all day writing it because it's so hard and it's so frustrating. So this is why people enjoy writing in Python, because they can just express themselves and get things done. Other questions, other thoughts? All right, let's then start talking about files. And this is going to mark a bit of a pivot in the course. We have gone over the main data structures. There are all sorts of variations on them. Variations on dictionaries, variations on tuples, variations on lists, but for the most part, these are the main ones. And once you understand how they work, that's a matter of just getting better at working with them. But what we're now going to do is deal with something that's totally different. It's not exactly a data structure, but it's not exactly not a data structure. And these would be files. Now, we have to get some definitions out of the way here. All of us have viewed files on our computer, right? Here's a PDF file, here's a Word file, here's a PowerPoint file. What is a file? A file is basically data. You can imagine it to be a data structure that has been put onto disk. What does that mean, put onto disk? Well, it means that basically the program originally wrote some stuff to disk that it's able to read back. Right? And you can think of this as sort of like the invention of writing for humans. So humans were talking for many years. Some were talking too much. And basically at a certain point, they developed the idea of writing. And the idea was then I could give a message to someone else. And that message, the person getting the message wouldn't have to see me or hear me. I might not even be alive by the time that second person gets the message. And yet the message is still good, and it contains all the information that I originally wanted to express. In the same way, a file is a bunch of data that expresses something that was written or said long ago, or maybe not so long ago, that we want to now use in our program. Okay, but what sort of data structures are being stored there, and how are they stored, and how are they dealt with? So you have a bunch of different kinds of files. The files we are going to be dealing with are all going to be text, strings, what you might have seen as like plain text files. We're not going to be dealing with Word files or PDF or whatever. Those are binary formats that when you load them into Python or any other language, you need to start taking them apart and understanding them. It's like a mess. And truth be told, I have no idea how to do any of that. I just use libraries. I use modules that other people have written that deal with it for me. But a lot is actually done with text files, and it'll give you a good sense of how some of this works. And so the thought you have to have in your head is, okay, how can I take data from this file on disk, read it in, and turn it into a data structure? Maybe that data structure is as simple as a string, because I'm just going to be reading text. But maybe I want to read it in and turn it into something else, something more interesting, something more exciting, something more useful. Maybe it should become a list. Maybe it should become a dictionary. Maybe it should become a list of dictionaries. There's no end to the different kinds and combinations of ways that you can translate from a file into a data structure. And very often, especially what we're going to be doing here together, there is no official data structure that you should be reading into. It's up to you how you want to parse and interpret it. So if we are going to read from files, how are we going to do that? So Python actually cannot talk to the disk. Imagine this, right? You got a disk, and it's a bunch of bits. It's a bunch of magnetic, it's like as someone described to me once, very high speed magnetized rust. That's more or less what disks are. Now, they're incredibly amazing things. People spend like a lot of time, a lot of money, a lot of energy learning how to make them more reliable. I do a lot of work with Western Digital, which is a company that makes not hard disks per se, but like flash drives and USB drives and so forth. And the people I talk to there describe the technologies behind the scenes as incredibly, incredibly complex. I totally believe that. So I don't want Python just going and sort of mucking around with those bits on the disk or whatever it would be on flash drive. I want it to go through someone who actually knows what's going on. And that's what we have to do. We have to go through an agent. So when we say, I want to read from a file, what we're really saying is, hey, Python, would you talk to the operating system? And the operating system will talk to the disk. And the disk will actually do its thing. And all those layers have sublayers and sublayers and sublayers. And I will get the data back from the disk. It works so smoothly, it's hard to remember that, or it's easy to forget how many layers and how many different things are going on there. So let's say, and I asked you guys, or I gave you a link. I'll put in the chat as well here. If you go to files.learner.co.il, that's where I put in the files for my courses. And the first link there, I'll just look at it here. If you look at the first link there, that's a link to a zip file. Let's take a look. Oh, there we go. If you have basic and intro Python. We're probably not going to use all those files. It's just an easy way to get them to you. If you download those, you will have the text files that I'm looking at here. So let's say I want to look through one of these files here. All right, so I'm just going to do like a little bit of magic here. What do we have here? Let's do nums. Actually, that's a little hard. Let's do mini access log txt. So what is this? What is this mini access log? Well, you might or might not know that every time you visit a website, that website logs your visit. It says, I know who, well, they might know who visited, but they definitely know what kind of browser that you were using. They definitely know when you visited. They definitely know what you requested. And this is true for each page, for each image, for each script, for each icon, for each everything. And by the way, here's a little trick. What if you put an image on your site that is almost invisible? It's like a clear 1 pixel by 1 pixel image. Yeah, well, that still counts as a request. That's still going to be logged somewhere. What if I take my 1 pixel by 1 pixel image that's invisible and I have put it on someone else's website? Well, then every time someone visits that website, I will know because it will be retrieved from my server. You know what I've just described? Facebook, Google, and so forth, and how they can track you very easily because they put their pixel on many, many sites. All those websites that say, like us, and we'll give you whatever. If it's on the website, it's tracking you. Okay, so we're getting device type, IP source, you're getting all sorts of information. So I'm just going to look at the top. I'm using some Unix magic here, mini access log.txt. So this is what that log looks like, and this is from about 10 years ago already from my server, and it's not so super exciting. Now this looks like a lot of gobbledygook, but actually this gobbledygook has a format to it. Every line of this file represents one request. So if I start up a new server and I have 100 requests, either from the same user or one request from 100 users, there are going to be 100 lines of the file, each one of which is going to describe the IP address. Where did they come from? And then on what date and time did they make the request? What did they request from me? What was their response? How many bytes did I respond with? And then what is their browser? And you can get even more information if you really want. It's like all sorts of crazy stuff there. So let's say I want to know what were the IP addresses that people were using to access my website. That's a great question, right? Like that's something that people will actually want to do. So how am I going to do that? Well, the first thing I have to do is somehow read this file into Python. So how am I going to do that? Well, I'm going to say here, f equals open mini access log.txt. Now there's several parts to this. The first part is the open function. Open says, hey Python, I would like you to ask the operating system to connect to this file. Notice the operating system is in the way there. Back in the olden days, like in the 60s and 70s, programs would just talk to the disk directly. Nowadays, even if that's possible, I don't think it is, it's considered a really bad idea. It's also security issues and efficiency issues. So what happens is you say, I'd like to open a file, and the operating system says either yes, here is a file object, here is a file handle, here's a way of talking to the file. It gives me an agent to talk to it, and that's what we're going to stick in F. Now what can I put in open? Look, I'm giving it a string. What is that string? It's the name of the file. I happen to know that the file is named that. And I also happen to know that it's in the current directory. If it's not in the current directory, I have to give it a long path, right? Wherever the file is located. And don't forget, if you're on Windows, if you give it a long path, that's fine. Just don't forget that you either should use a raw string with your backslashes or some other sort of black magic. Or switch to Unix. Okay, let's try a better one. People were convinced for years that normal humans are going to switch to Unix. Joke's on me though, because I never believed it. Now Android runs on Unix, of course, and the Mac does as well. So we're getting closer, All right, so basically I'm saying to Python, open up this file and give me back a file object. Give me back this object, this agent that I can use to access the file. And sure enough, if I say F, we can look at this object we got back. And this is how it presents itself. What the heck is going on here? Okay, every object can sort of present itself a different way. So far, lists, strings, dictionaries, they all sort of know how to present themselves. If this file object is doing something a little different, it's telling us about itself, but not the actual contents. It's saying, oh, you think I'm a file, but I'm actually an IO text IO wrapper object. Very complex. Actually, there are a whole bunch of different file objects in Python. There's a whole family of them. We actually call them file-like objects because they're each a little different from each other, but they do roughly the same thing, meaning allow us to read from and write to the file. So we've opened up the file, and we'll be able to do that. It's a text file, we should be fine. Here we have the name of the file. So actually the file object knows what the file is that it's reading from. And then we see mode equals R. This we did not talk about. When I open a file, I can either open it for reading or I can open it for writing. You might be saying, that's ridiculous. When I open a Word file and I'm working my word processor, I'm typing away and I save, see, I read the file and now I'm writing to the file. Aha, but probably every time you hit save, it's opening the file for writing and writing to it from scratch. It's not really the same operation. Each time it's reading it from scratch, each time it's writing it from scratch, which is why it can sometimes take a while to write. And also the Microsoft formats have all this stuff associated with them that allow you to sort of say, oh, and since last time I added this and this and this. So right now we're just reading from the file. How did Python know we wanted to read from the file? Because we didn't say anything else. Because we just said, yeah, I want to open this file. And if you don't say anything else, the odds are you're probably going to want to read from it. Finally, the encoding. We are going to assume that all of our files are using what's called Unicode or UTF-8, meaning that the file can be written in any language with any number of characters from different alphabets. We're not going to worry about that right now. It is a world of pain in and of itself. So now that I have my file object, I can ask it for the contents of the file. I'm going to read it all in. And how can I do that? I can say f.read. f.read returns a string containing the file's complete contents. Is this a good idea? This is a terrible idea. Well, the good news is they got a string, right? And the good news is it actually contains all the information there. So that's good. The bad news is that this was a really dangerous, foolish thing to do. Did I know how big this file was? Did I know how big the string was going to be that I was going to get? No. So if I open a file, let's say, I remember I've worked at places and worked with clients where they had log files that were, hundreds and hundreds of gigabytes long per day. So if you're going to open a file like this and just, I'm going to read it, you could run out of memory on your computer. Also, okay, big shot. Now you've got this long, huge string. Go search through it for these IP addresses. Good luck. So this is a really bad way to read through files. Python does allow for it because we might very well want to do this. Small files, it's fine. But when you get to bigger files, not a good idea, and that's most of them. So how can we do it? And this is where super cool stuff comes in. I'm going to open the file, and I am going to use a for loop on it. That's right. I can iterate over a string with a for loop, and I'll get the characters one by one. I iterate over a list or a tuple, and I get the elements one by one. I iterate over a dictionary, I get the keys one by one. I iterate over a file, and I get the lines of the file one by one. Because so many files are formatted in this one by one by one. Oh, Leon asked a fantastic question here. If you read the file, does it lock the file? The answer, as always, is yes and no. So in the world of Unix, no, not at all. You open the file for reading, great, 1,000 other people can open it for reading, nothing will happen. But what if someone tries to write to the file at the same time as you're reading from it? In Unix, it doesn't care. It will happily let you do whatever you want, unless you explicitly lock the file. And there are ways to lock it, but we're not going to talk about that here. So, but in Windows, it turns out that if someone is reading from a file and someone else tries to write to it, Windows will actually stop that. And that's sort of different operating system philosophies there. So you probably shouldn't just keep the file open forever, but for our purposes, it's going to be just fine. But yeah, locking, please. Who locks their files? That would be ridiculous. Okay, so let's see what we got here. All right, so I'm going to iterate over. I'm going to say here for one line in F, print one line. Now it's going to look a little weird, okay, but it's going to work. And this actually works. Now, how much memory am I using here? Very little. Because I'm using the memory for line 1, then the memory for line 2, then the memory for line 3. I'm only asking Python to create a string as big as the current line. And then I'm reusing the same variable next time around. And I'm reusing the same variable next time around. So at any given moment in time, I'm only using that line's memory. All the rest of the memory has been garbage collected, has been freed up by the system. This is dramatically, dramatically more efficient. And so this is the standard way to read through a file. By the way, we can shorten this a bit. I can say here, let's just keep that. I can say here for one line in open mini access log.txt. Right? Nothing's stopping me from doing this. In fact, this is a really good. What about the empty lines? Yeah, Ronnie, you caught me. I'll talk about that in just a moment. So what happens here when I say for one line open mini access log print one line? Well, open is returning a file object. And then we're going to assign it, well, then for turns that file object and says, give me your next, give me your next, give me your next. And each one of those next lines is assigned to one line. Then what do? We print one line and we get the same result, except that I forgot a colon. But other than that, there we go. So sure enough, we're getting the same results. And this is like super, super standard. But as Ronnie noticed, we have some blank lines here. What the heck? What's going on? Well, it's observing the 2-meter rule during Corona. No, what it's really doing is, I'm full of these bad jokes, folks. What's really going on is this. Basically, when the for loop asks the file object for its next thing, it says, give me your next one, give me your next one, give me your next one. The file object obliges by giving it the next line up to and including the /n, up to and including the new line character. And so what's happening is one line, the last character in one line is the new line character. So when we print out the line, we're going to get that new line. But print also puts in a new line. So we actually have 2 new line characters here. One from the line itself and one that print is adding. So if you do this though, it does not print for one line in F. Oh, okay. So Duccio, did I get pronounce that correctly? He's saying this is not printing. What's going on? Well, if you do it like this for one line in F, then you're using the same object each time. And when you get to the end of the file, it stops. It stops the iterations. And so you can reuse, like if I do this here, if I say for one line in F, print one line, then again, for one line in F, print one line, it's going to run out of lines when it gets to the end of the first iteration. Here, though, we're getting a new file object each time because I'm running open each time. And thus, each time I'll go through everything. And thus, this is better, not only like cleaner, but it ensures that you're not going to be stuck in that way. So getting to the end of the file and then trying to iterate and it's too late. Okay, so how can I deal with this? The easiest way is to tell print end equals empty string, meaning don't tack a new line onto the end of each print. I'm set. And now we see that they're all like stuck together there. I can't say enough how standard this idiom is in Python. We are constantly reading from files, and we're getting them line by line. So what is each line? This is one line, then this is one line, then this is one line. Now here is the really cool thing. What if I don't want to print the whole line? I mentioned before I want to print out the IP addresses. So how, oh, we could strip, absolutely, Ron is totally right. Instead of, so one option is to say to print, don't add a new line. The other option is to say to print, yeah, print your new line, but let's get rid of the new line from one line. We will get exactly the same results. Absolutely, absolutely. So here's the thing. I want to see what the IP addresses are in each line. I could not care less about all the other data. So here is what I'm going to do. I'm going to say one line split. What does one line split do? It returns a list of strings based on one line. Watch what I'm going to get. Don't freak out, right? So what I'm showing is the first line's been turned into a list, second line's been turned into a list, third line's been turned into a list. Each line has been turned into a list. Why would I do this? Now, the ultimate thing. I got the IP addresses. Because what did I do? I said, Python, open up this file, mini access log, and give me one line at a time, and stick the current line into the variable one line. Then I said, take each line as we're grabbing it, split it into a list, and give me only, print out only, the first element, the zero indexed element of that list, which happens to be the IP addresses. This is how we can produce reports based on log files, based on data files, based on all sorts of other stuff. It's so incredibly powerful. And once you see all the pieces come together, I think, at least for me, it's pretty straightforward also. But there are a lot of ideas packed into this little bit of code. What can we do with this? Well, I can print it out. But I'll show you in a moment, we can do some other stuff too. Other questions, any other questions people might have? Okay, if there are more questions, don't be embarrassed, just ask away. I'm here to try to answer them. Let's try this. I'm going to paste this code into the chat to help people maybe type a little faster. All right. I'm going to now give like a mini exercise, and I'm going to go over it. And this connects with what we did before. What I want to do is I want to find out how many times did we visit or were we visited by each IP address in the log file. Meaning, how many times did this IP address visit us? How many times did this IP address visit us, and so on and so forth. Okay, I'm gonna give you 2-3 minutes to think about this. I realize that there might not be enough time to actually implement it in code. That is fine. Don't worry about that. I want you to think about what would you do? How would you do it? What data structures would you use? All right, so I'm gonna be quiet for about 2 minutes now. I'll let you think about it, and then we'll go over it together, and then we'll do a little more stuff with files with the time remaining. Okay, let's go over this together and see how we can use these parts that we've talked about and seen to try to solve this sort of problem. So my question was, how many times were we visited by each IP address in the log file? And again, you can imagine this log file could be hundreds and hundreds of gigabytes long just per day. But I still want to know, like, per day, per week, whatever it's going to be, how many times were we visited? So we don't need all the data there. We just need the IP address and then to accumulate somehow. So I'm going to take this loop. I'm going to take this loop and it's going to really be useful. But I'm going to first create a dictionary. Counts equals a dictionary here. You're starting to see where I'm going with this? We can use counts just like we did before with words and with characters, with a dictionary. The keys will be IP addresses and the values will be the counts. And then what I can do is I can say here, IP address equals one line split 0. So what am I doing? I'm taking the current line, splitting to a list, keeping only 0, which is the IP address. And I'm sticking that in a variable IP address. Now I can say if IP address in counts, then we'll say counts of IP address plus equal 1. Else counts of IP address equals 1. And now when I run this, whoop, we're done. If I look at counts, the dictionary, look at that. We've now kept track of how many times each of our IP addresses visited us. And someone really loved us. Most people, not so hot. So look at that. And was it like 9 lines of code, including spaces? Just get rid of this so we can actually have 9 lines there. We were able to open up a file, iterate over it, and analyze it. Not bad, huh? And this is used in so many ways. Oh, if you want to see the top 3. Okay. So, you know what? Let's talk about that a little bit. Let's talk about that. We haven't really talked about sorting so much. So, so what we have here, right, if we want to see, trying to think. Okay. Watch this. You might, I think we talked last time a little bit about iterating over a dictionary with items. So if I say here, like for, let's say IP address count in counts items, print, let's do an F string here, print F string here of IP address, count. And now this is like exactly what we just got. Maybe, okay, but that's of course not the top ones. So how can we get the top ones? Well, in order to do that, we would need to sort it somehow. We're going to need to take this counts items and sort it. Well, so what if I say here, sorted of counts.items? Will that work? Well, sort of, right? Because what is it doing? It's actually sorting by the keys here, by the strings. Yeah, so how can we do this a little better? Well, the good news is that sorted returns a list of tuples. But I don't want to sort by the key. I want to sort by the value. So this is a little complex. So I'm warning you right now, if it starts to like make your head feel fuzzy, it's not you, it's me. This is a little complex, but we can basically tell sorted, don't sort in your regular way. Don't sort by the key. Rather sort by the value. So how are we going to do that? Well, we're going to need a little help. We don't need help, but we're going to use it. From, goodness gracious, from operator, import get item getter. Sorry, item getter. And then I'm going to say here, key equals item getter of 1. What the heck? So item getter is a fancy function that creates other functions. It's like a function factory. And what we're saying is, hey, create this function factory such that whatever we use it with gives us back not index 0, but index 1. And then when you're sorting, don't use the first thing, use the second thing. Guess what we get back? We get back sorted by value, not by key. 1, 1, 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 16, 22. Okay, that's great. But yeah, I didn't want it lowest to highest. I want highest to lowest. Oh, easy enough. I'll just say here, reverse equals true. Shoo. Now I have a list of tuples in which it is sorted by value, not by key, in descending order. But Ronnie's question was, how can we get only 3 of them? Well, it's a list, right? So we can just use a slice there. A slice of up to 3, and now we have the top 3 ones. This is the power of these data structures. Oh, I will definitely put this code in the chat. Yeah, good point, good point. Right? Like the amount of stuff you can do in one line, 2 lines of code is just immense. But it's powerful, it's complicated, and this whole business here of functions that create other functions, that return other functions, it's complicated stuff. All right. Okay. The key idea, no dictionary puns intended, the key idea here is I want to think of my files as containing data that I then want to read in and turn into a data structure, right? So the question is, what data structure do I want to create with it, and from which part of the file? Do I want to read the whole file, a little bit of the file, most of the file? Probably going to read it line by line, and I'm going to do something with each line. Let me show you one more thing with this. So we've already seen that I can say for one line in open mini access log txt, in one line. Fine, so far so good. What if I'm totally uninterested in any line that claims it was a bot? Well, how do we know if it's a bot? Bots in those days, 10 years ago, were much more polite than they are now. They tell you somewhere in the string here, it'll say bot. So I'm going to have like a stupid rule, but I'm going to say this anyway. If the line contains the letters BOT in a row, I don't want it. So how can I print all the lines except for those that are bots? If I can say here, if bot in one line, continue. And this is a classic way to use continue in a for loop. I basically am iterating over something, and I have a whole bunch of if statements at the top. If it's this, go back. If it's this, go back. If this, go back. And continue means go back, go to the next item. I don't want anything to do with this. And then because it's continue, we don't have to have an else, because we know that if we got to line 5 there with print, we know that like it did not contain bot. And then what I can do is I can say print one line split 0. So what this means is these are the IP addresses that were not from bots. And of course I can use anything in there. I could say, I don't want anything from google.com, right? Or I could say here, right? I can do all sorts of things. I could say Google, at the time Yahoo actually existed. So I could say, if yahoo.com in one line, continue. So we can like really get rid of a whole lot of stuff there. We could even say, well, I mean, there are all sorts of other things we can do, right? So basically, this gives us incredible power to read data from disk in a simple format, line by line. But it turns out lots and lots of files are designed that way for this reason, because it's easy to write a program that reads from it in this way. More questions or comments about this stuff? By the way, when I first learned this, like this was just mind-blowing for me, because when I first learned like how you work with files in a programming language, it was long, it was annoying, it was difficult. And the fact that you just like pop it open, iterate over it, treat it as a string. Oh, I know what to do with strings. And because it's a string, I can do all sorts of like familiar things with it. And oh, I'll treat it as a list because I can split it. Amazing, amazing stuff. And of course, if you want slightly harder things, and who doesn't, right? Let's just take a look at the head of mini access log, right? You could, oops, mini access log. You can imagine saying, well, let's not grab the IP address. Let's grab the timestamp. Let's grab the date and find out how many there were, how many accesses there were per date. Let's actually do that in a little bit. Oh, Krishnendu asks, I work a lot on Excel. Is it as easy to handle them as text files? The answer, the answer is yes and no. For us to do it ourselves, it would be immensely difficult. Like for us to open up the Excel files and deal with it. But it turns out we don't have to, because Python has a whole lot of libraries that know how to work with Excel. The best one is Pandas. Pandas is not designed as a library to work with Excel. It does all sorts of other stuff, but it just happens to, well, excel at working with Excel. But there also, I think there's one called PyExcel that I used for a while. Nowadays, I would just use Pandas because I use Pandas for tons of stuff. But Pandas, yeah, if you go to, I think it's like pandas.pydata.org, I'll put that in the chat. Pandas is amazing. I did a course, like I have a paid course in Pandas that I sell online. It is 12.5 hours long. It is like a monster of a course. And if I got to even 10% of the functionality in pandas, I would be stunned. It is just an incredible, incredible library that does so much. But along the way, it also happens to work with Excel pretty well. If you're looking for something else, you can probably, I think, again, PyExcel might do it. But there are all these little, like, we'll talk about this when we talk about modules in a few weeks. But yeah, this is really amazing stuff. Let's actually see if I can do the timestamp thing, because that's actually harder. So I've got to, like, put pressure on myself. And then I think we'll close up for the day. And then we'll talk about more about files next time. And next time we'll also talk about writing to files. So let's see what we can do here. So I'm gonna do this. I'm gonna say, what's one line? And I have one line left over from before, from my last for loop. So this is great. So what do I want to do here? I want to find this square bracket, right? Because I know that the first opening square bracket, that's where the timestamp is going to start. So I'm going to say, like, timestamp start equals one line index of open square bracket. And if you're thinking, wow, this is like how we're going to mess around with it, yes, this is how people really do it. So now I'm going to say here, one line from timestamp start until the end. Watch what I got here. Ha! See, now I got that whole timestamp there. In fact, I'm going to say here +1, because I don't care about the square bracket. Now what I'm going to do is I'm going to try to look for the colon, and I'm going to get rid of that. So I'm going to say here, colon is at one line, timestamp start colon dot index of colon. Let's say colon index. And now I can say here, show me one line. I'm going to go back over this. I know there's a lot. One line from timestamp start plus, oh, actually, I don't want that. Fine, you know what? Plus timestamp start. Right, plus one line timestamp start plus colon index. Oh, timestamp start until colon index. Look at that. Now, how the heck did I get that? So let's go back to what we've got here. I said, I want this stuff here for my string. Meaning, let's find out at what index that square bracket is. That's what I'm going to do here. And then let's find out where that colon is. Well, that colon, if I start here, colon's going to be past that. So I'm going to say here, the colon index is going to be starting from where the timestamp is, get that index, and then the timestamp start. And then I can just say one line from the timestamp start to the colon index. There we go. That's my date stamp. So now what I can do is I can plug this back into a for loop. I can say here, dates equals dictionary. Why do I use a dictionary? Because dictionaries are great. And then I can say here, for one line in open, mini access log.txt. What am I going to do with that one line? I'm going to do all this stuff. Bam. I'm going to say date equals, or let's do one date, make it a little clearer. And then what am I going to do? Exactly what we did before. I'm going to say here, if one date in dates, then we're going to say dates of one date plus equal 1. Else, we'll say dates of one date equals 1. And now what are we going to get? Let's run that. We see that we had, 103 on each of 2 days. Well, that was a lot of work for nothing, huh? Oops, I guess I should have had a much more varied log file. But you get the point of what I was trying to show, yes? Hopefully, yes. I'm going to show you one more cool thing with this. This is actually pretty cool. Hopefully cooler than the dates. I'm going to go back here and get our counts for the IP addresses. Watch this. All right. So we saw before that I can get all the counts for the IP addresses. I can say like for, let's say IP address count and counts.items print. We'll say here IP address and count. And we see here that indeed we are getting IP address and count. Well, it turns out we can mess around a little bit with how these things are displayed. And I'm not going to like show you all the intricacies here of the F strings, but I can say inside of the curly braces, IP address colon, let's call it 18. And that means print the IP address on a field of 18 characters. Okay, interesting, but not amazing. Here is the amazing part. Did you know that in Python I could say 3 times 5? Oh, yeah, you probably knew that. Did you know I could say x times 5? That's right, I can multiply an x times 5. And then what do I get? 5 character x. Who cares? Why am I showing this to you? because I am not now going to say count. I'm going to say count times X. What do I get? A histogram. Amazing, amazing, right? Like, it's just mind-blowing. You can open up this file, iterate through it line by line, stick it into a dictionary, go through the dictionary, print it out as a histogram, and then even your number-challenged colleagues and managers will be able to understand that this IP address was much more popular. Pretty snazzy stuff, huh? Any last questions, folks, before we close up for the day? All right. So the plan is that next week we're not meeting. In 2 weeks, we're going to meet and we're going to talk about writing to files, a little more with reading files. I will definitely put some stuff in the forum. Then we're going to talk about functions for 2 weeks. And then we're going to talk about like an open Q&A. I think that's how we're going to end up this course. Folks, thank you so much for joining me again. It really gives me incredible pleasure each week to see you. Have a great week. Have a great 2 weeks. I'll see you in the forum and have a wonderful week. Sakira asks, can we use readline? The answer is don't. Readline reads one line at a time, and you almost never want to do that. So, okay? But like you can, just don't. All right, folks, have a fantastic, fantastic weekend. Stay safe, and I will see you all online. The video should be up. I'm going to put it up within the next hour or so. It should be ready. I have a new computer, so it's processing video faster nowadays, I'm happy to say. All right, guys. Bye-bye. I'm going to sign off now.